So, we've talked about algebraic terms, right? What pieces are algebraic terms? Last time we did our second lesson on algebraic terms, which was operations with algebraic terms. And today we're going to do the third part, which is mixed operations. In other words, you're going to have multiplication and division, and then we're also going to have roots. Not page 3 in our book, page 3 of our continuing saga of the algebraic terms. In the book, we're on page 13. All right. So we're gonna mix up some operations. So we're gonna have some division, we're gonna have some multiplication, and we're gonna have some combined like terms. These are great exercises to get you prepared, right? Now, the first thing I am going to write is the most important thing you'll ever hear a math teacher say. The most important thing is to first, not later, identify the operation. If you don't know what you're being asked to do, you won't be able to do it. Imagine that. And students, especially there's lots of stuff going on, just like to jump in with both feet and go, yay, right? I can do this, I can do that. Just do something. And I even know math teachers who do that. Just get in there and start doing something, right? Instead of staring at it. Well, baloney. You get in there and ask yourself the question of what operations you have. Because in mathematics, is it a little important that you do them in an order? Do you remember that? Order of operations, right? Bidmass or bedmass, whichever one you use, I don't care. But, yeah. So it's important that you know which one to do first. It's also important because the rules are different, right? Is combining like terms the same rule as division? No. So you have to be careful. Is division the same rule as multiplication? No. So you have to pay close attention to the operation, right? And besides, slowing yourself down and taking the time to say, that's multiplication with algebraic terms. That also triggers in your mind what you need to do.
Will it not tell us?
Okay?
Like, this is
No, it's not. It just says simplify. Okay? And remember that word simplify? You'll see it all the time. Most people associate it with fractions. It doesn't really mean reduce a fraction. Simplified simply means do the math. It's the all-purpose word that says do the math and do it in order, according to the order of operations, right? So if you see the word simplified, that just means do the math. You'll see it for everything, right? So what's the most important thing you can ever do first?
Identify.
Right, because it'll tell you which steps you need to go to be able to work the problem, okay? And we don't take the time to do this. We just jump in. So be careful, okay? And the word simplify simply means do the math. But remember, when you're doing the math, you do it in order. So let's look at a couple of these. Again, remember, doesn't matter what day it is, doesn't matter what page it is, doesn't matter what we're talking about. I'm always going to do which ones? Even ones. And your homework is always going to be the odd ones. So do I need to write down the homework every day? No. You need to make a note of which pages we do, and you just know that you're going to do all the odds on that page unless told otherwise. Okay? Got it? We all on that? We're okay there? Good job. I knew we were. So look at number 2. We're on page 13. Okay? All right. So we have x squared, y squared over xy quantity squared. Quantity just means bracket, the whole thing. Quantity means the whole thing, right? So bracket squared, if you prefer. Now, one thing that we haven't talked about with fractions, because we haven't been dealing with fractions much in this, is if you have a fraction, right, some numerator over denominator, the order of operations says that you first simplify the numerator. Second, simplify, which means, of course, do the order of operations, the denominator. Then third, use the fraction bar. If you have any fraction, right? There's an order of operations for fractions. And the reason for that is that even though you don't see it, there's a bracket around every numerator and every denominator. And when do you do brackets? Always first. So even though you don't see them, they're there, which means you have to simplify anything you can in the numerator, simplify anything you can in the denominator, and then use the fraction bar. And the fraction bar simply means to do what operation? Divide. There you are. So in the top, I have x squared, y squared. Nothing going to change there, is there? No? Okay. In the bottom, I have a bracket. So I need to work that bracket out. And it's xy squared, which means take xy times another what? Xy. X times x is x squared. Y times y is y squared. Now I'm going to use the fraction bar. So x to the second divided by x to the second is x to the 2 minus 2, which is x to the 0, which becomes a what? 1. Y to the second divided by y to the second is y to the 2 minus 2, which is y to the 0, which also becomes what?
1.
But do I need to write another 1 if I already have one there? No. Nope. So what is my answer here? No, I hate that.
I'm sorry.
If you say can't, I'll show you why. Later, when we have stuff like this, and you will, y'all are going to say, oh, those y squareds cancel out. And I'm going to tell you, and I'm going to say, oh, well, you're going to be in year 11 for the rest of your life. No, because it doesn't work. And cancel is another one of those shortcuts that's been done to you. The book even mentions it. I hate it. There's no such thing as cancel. Anything divided by itself makes a what?
1.
Do you always have to write the ones? No. That's what's really happening. Cancel gives you the idea that things just go away. Nothing ever just goes away. Right? It can turn into a 1 which you don't need to write. And I know it may seem like I'm just giving you all kinds of information that you've already have other information for. But you know what? I know where you're going. I taught at the university. I know what university math looks like. I know what higher order math looks like in these courses, right? Year 12 and year 13. And I know exactly the kinds of problems that most students have. And they're little picky, stupid things because you've learned shortcuts.
Well, that's not your fault, though.
No, but it's my fault if I don't fix it.
Yeah.
And if I fix it, it's your fault for not fixing. All right? Do you see?
Yep.
That's why I'm so passionate about that kind of thing. And it makes me, I'm sorry. It hurts me when y'all don't do well. I feel sad. Here we go. Number 4. 3b squared divided by b to the third. I literally don't worry about what I do. 1.
Just one. There's nothing.
Yeah. Okay. All right, here we go. We got a fraction, so we need to simplify in the top. I can't do anything inside, but is there an exponent on that bracket? Yep. So that literally means 3b times another 3b, which is 3 times 3 is 9. B times b is b squared. Okay. In the bottom, it's b to the third. Nothing changes there, so just bring it over.
Is that the answer? No.
Now, am I done?
Fraction bar.
Fraction bar means to do what? Divide. 9 divided by nothing just stays 9. B to the second divided by b to the third is b to the 2 minus 3, which is b to the negative 1, which tells you that b should be where?
Why do you have to take it down? Because the bigger number is at the bottom.
Wait, I didn't get the previous one.
Do you Mr. Self-Find lost at the b2 minus 3 equals b?
Remember, you're dividing b's by b's, right? What do you do when you divide? You take the exponents and what? Subtract them. So the top exponent is a 2. Bottom exponent is a 3. So that's why I did 2 minus 3. Which gives me b to the minus 1, which tells me it shouldn't be in the top. It should be where?
In the bottom.
In the bottom. And I really knew that because most of the b's were in the bottom, so that's where the b's are going to land.
So it started.
Sorry. Sophia got it.
Wait, Can we erase the previous one?
Wait, hold it right there.
Okay.
I
Come on, guys. Here we go. Look at number 8. They get uglier, but that doesn't mean they get any harder because the steps are always the same. Zy divided by 5zy to the 4th, all raised to the 2nd power. Also known as quantity squared because quantity means the whole thing squared. So if you hear me say quantity squared, it's just it's an American thing, probably. Okay. All right, now, first we start where? Inside. And inside, this one, we have some division to do, right? What is the number here in front of this? Yeah, and 1 divided by 5. Can you divide a 1 by a 5? No. So you just get what?
1 over 5.
Excellent. Then I have z divided by z, which is something divided by itself. So you cannot say cancel to me, but you can, if you just have to, say they divide away. But what do they really make?
1.
A 1. And do you need to write the 1 though?
No.
No, because I already have a number there. Right? Because literally it's 1/5 times 1. And that doesn't make any sense, right? 1 just gives you 1/5. Okay? So I will allow you to say divides away if you just cannot stand it. But if you say cancel, I'm going to look at you funny. Okay? All right. Then we'll do the y's. Y to the what? First divided by y to the 4th, which is y to the 1 minus 4, which is y to the what?
3.
-3, which means it's going to be where? On the bottom. Right? Which I knew because the most y's were in the most factors of y were in the bottom, so that means it's going to land up in the bottom. Okay? Now, we've completely done the inside, but the next thing I look for is a what? Exponent. Do I have one on the bracket? Yep. And it's a square, so that means take everything in the bracket and multiply it times what? Itself. So, let's do that. 1 times 1 is? 5 times 5 is? Y to the 3rd times y to the 3rd is? Boom, we're done. I'm sorry. I get so excited. It's the little things that make me happy.
Wait. So why does the 6 would be on the side?
No, because it's in the bottom. If it was in the top, you can drop it to the side. Okay, there we go. I'm waiting. I'm okay with that. So 4z to the 5th. Oh, you're going to love this one, guys. Raised to the 3rd power. Then y over y squared z. Now, you can approach this one in a couple of different ways. I'm going to tell you that I would just doggedly follow the order of operations. Okay? So, first we'll simplify the top, right? So just take it off to the side and ignore that there even is anything else. Okay? Now, first thing we have to deal with is the bracket here. So we have this bracket, 4z to the 5th. There's nothing to do, is there? So, then we have an exponent on the bracket. You're not going to like this one because I'm going to expand it. That means you're going to multiply it times itself how many times? 3 times. Now, is that y in the bracket?
No.
So we're just going to leave it on the outside, but it still exists. Don't lose it. So now let's multiply. 4 times 4 times 4 is? 64. 4 times 4 is 16. Times 1 more 4 is 64. Don't worry about it. Okay? Z to the 5th times z to the 5th is z to the 10. Be careful, add. Yep. Times another z to the 5th is z to the 15th. And all of that times y, just times y.
Right.
Okay? So that's the top. Yes. So that's the top done. Now that's still over y squared z. Right?
Yeah.
Now, there's something wrong with the top one when you look at it. What's wrong with the top one? It shouldn't be z, y. It should be y, z. But it doesn't really matter for us. Well, as long as we have it in the right order when we finish off. But if you want to, think of it as, remember that they really should be in alphabetical order. So when I multiplied this together, I should have put the y first. Okay? Not going to make a difference to your answer. Now, what's the fraction bar mean to do?
Divide.
So 64 divided by 1 is y divided by y squared is y to the 1 minus 2, which is y to the, which means it should be where? In the bottom. Z to the 15 divided by z to the 1, z to the 15 minus 1 is z to the 14, and since it's positive, it stays in the top. There you go. It looks, they look horrible, but they're really not bad.
But then when I did it by myself,
Yeah.
Well, because you got to train yourself to ask the questions like I do. That's what happens is that you're not asking your no, don't do like. Please, yeah, avoid that. And for some reason, I've never heard. I don't understand. In New Zealand, they call them surds, which blows my mind. You don't know that word? Good. I hate that word. It's a stupid word. But anyway, so there you go. We're going to talk about its roots. Now think about something. Where do you think of, if you hear the word roots, what do you think of?
Tree.
A tree. And where are its roots?
In the ground.
In the ground. And where do you think the tree starts growing first?
In the ground.
In the ground. So the roots are the beginning of everything, right? Does that make sense? Okay? Well, yeah, but when it starts to grow, the roots are the first thing to start. So what we're talking about when we're talking about a root, guys, come on, is we're literally talking about what thing, and you can't say number because remember we're talking about algebra, right? What thing times itself n times, now just write it down and I'll explain it. N times will give me the thing inside the radical. And don't worry about the word. I'm about to define the word and show you what they mean. It's just a picture. The radical. Okay?
Can we just explain this one? Because we have 5 minutes.
Yeah, it's so easy. It's so easy, and you don't really know what you're doing. Okay. First of all, let me define what a radical is. You've seen a radical.
I thought he said rattle, like rattles.
A radical.
That symbol is the radical or root symbol. But technically, it's called a radical.
Oh.
Okay? The thing, or a surd. Yeah. The thing underneath, the thing that you're taking the root of, is called the radicand. It's the thing you're taking the root of. And there's a little number usually here, and that's the index. It tells you what root you're taking. Okay? Yeah, all right. So this is the picture. The radical is the actual whole thing, the symbol. Radical is the symbol. Okay? And the whole thing together makes a radical term. Because everything we do in algebra is built up of terms, right? So if it has a radical in it, it's a radical term. Does that make sense?
Is that something
The thing inside. The thing inside is just the radicand. The radicand is inside. That means the stuff inside is called the radicand. The index is the root you're taking. Because you can take any root, almost any root. You can't take the first root because that's silly because the first root of any number is itself. So, usually you will take the square root or the second root. Okay? So what a radicand does is it undoes an exponent. Okay? A radical is simply the opposite of an exponent. So instead of making numbers bigger, what do you think it's going to do? Make them smaller. Because an exponent makes numbers bigger, right? 3 times 3 times 3 gets bigger. But what we're going to do is we're going to take the bigger number and break it down into its smaller parts. Okay? All right? Yep, we just learned how to make them bigger. Now we're going to learn how to take them apart. Critical skill. All right? So here's what we're going to do. To take the root. Sorry, it's really bad, messy. I can't not write it there. Okay. Right. To take the root. Find the largest perfect square, cube, etc. Because you're going to be, this is the general directions no matter what route you're taking. So, and I'll show you how to tell what route you're taking. That will divide evenly into the radicand. Now, so what I'm going to do is we're going to make a chart of squares and cubes right now. Okay? So, if you have a root and you have a square and you have a cube. Now you can expand this to fourth power, fifth power, whatever. But this is just the first one. If the root is 1, squaring it means 1 squared or 1 times 1, which is also still what? 1. Times another 1 is still what? 1. 1 is its own everything. And so the cube root of 1 is still 1. The square root of 1 is still 1. The 16th root of 1 is still 1. It's the only number that happens, though. So what if the root is 2? 2 times 2 is 4. Times another 2 would be 8. So the cube is 8. 3. 3 times 3 is 9. Times another 3 is 27. So you're just multiplying the number times itself over and over and over again, right? 4 gives you 16 and
64.
There you go. 5 is 25 and 125, right? Okay? Okay? Etc. We could play that little game all day long, right? Okay?
2 cubed is not 8. Oh, it is. No.
Yeah, it is.
Cubed is 3.
2 times 2 is 4. Times 4 times 1 more 2 is 8.
I thought it was power 2, and I was like...
Yeah, okay. All right, now guys, so what we're going to do is we're just going to work backwards. Okay? So when we do it. So we're going to stop there because we're out of time. Just remind me where we are.
Oh my God, I can't believe we went to the last minute. Yeah.